Hello and welcome to Tribe Topper. In this video session, you are going to learn about double slit interference which happens due to diffraction at two slits. So first we should understand what is interference. So basically when two or more waves they meet, they combine to produce a new wave, which this whole phenomenon is called interference. So these two waves which I'm talking of, they can meet, they can be moving in the same direction at the same time, so they can get a new wave of a bigger amplitude, or they can be moving in opposite directions, they can give us a new wave with zero amplitude. So based on that, we have the interference as constructive and destructive. So when the resultant wave has a larger amplitude than any of the individual waves, the interference is said to be constructive. So as you can see here, this is one wave moving, right? And then there's another wave moving in the same direction at the same time. These two waves will interfere and they are going to give you a wave which is going to have a bigger amplitude. They are going to give you a wave equal to the sum of the amplitudes of these two individual waves. So if A is the amplitude of the resultant wave, it is going to be equal to A1 plus A2, where A1 and A2 are the individual amplitudes of the two waves. And when your resultant wave has a smaller amplitude, we call that interference as destructive interference. And when does the destructive interference happen? As you can see here, this wave is going in one direction and the other wave is going exactly opposite, that is out of phase. Then how are these two waves going to interfere? Their amplitudes at one point of time, when this is A1, the other one is negative of A1. So if they have equal amplitude, I would say this is A1 and this is going to be negative A1. So the resultant wave is going to have an amplitude of A1 plus negative A1. So that gives you a zero amplitude. As you can see here, you get destructive interference gives us a wave whose amplitudes is zero. So here from this diagram, this picture, it is very much clear that how the diffraction happens and the waves interfere with each other. So as you see here, there is a single slit and from here the waves pass. This is say, okay, we have sunlight. So if the moment it passes through this small slit, the waves they spread out. You might have seen something like this patterns formed in the rooms when light is coming from a small aperture. So now this is a diffracted wave. But now if these waves pass through the second two slits, so S1 and S2, these are the two slits. Now two waves, when they diffract, you see they will interfere with each other. So here where they are interfering, that the crest falls over the crest falls over the crest, all this line, there is a constructive interference happening and you get the bright spots. Even in the middle one, you have the brightest spot. So the constructive interference is happening along these. And where the destructive interference happens, that is a crest falls over a trough, you get the dark fringes. So your interference pattern is going to give you some dark and bright fringes exactly like it is shown here. So this point is known as the central brightest spot, or we call it as the central maxima, where the two waves from the slits S1 and S2 are going to interfere absolutely constructively. And then on the sides, but this is going to happen alternately. So at some points you're going to get the bright spots, at some points you're going to get the dark spots, and these happen, as you can see here, alternately. So let's find out the relationship between these fringe widths, or the gaps between the fringes, and the distance between the slits, and the distance between the screen and the slit, and the wavelength. So there is a relationship that is going to be very, very important. So as you can see here, we have taken small d, this is marked here. This is the distance between the two slits. So small d is your distance between the slits, and capital D is the distance between the slits and the screen. So this horizontal distance, this one is capital D, and S is the distance between, or separation you can say, between the two bright fringes, two consecutive bright fringes. So you can see this is S. So this is one bright fringe, this is the central bright fringe. So the two consecutive bright fringes, they have a separation S. And let lambda be the wavelength of the wave. Now, as you can see here, the waves that are going to be coming from this point, from A2, if they fall at a point O, which is the central point, and A coming from A1, they fall here. The two waves, the two rays meet at absolutely no path difference because they travel equal distances. So distance A1O is exactly equal to A2O. So they travel equal distances. When the both rays have traveled equal distances, that means the rays traveling from the slits A1 and A2, that they travel equal distances up to the central point O. So there is no path difference between them. And when there is no path difference, they are going to have a constructive interference. So when the constructive interference happens, that gives you the brightest spot at the point O. So that is your central maxima. But the two rays, the two blue waves that you see here, they are traveling a little bit of a different path. So A1B and A2 to B, the lengths of the path are different. So you can see how much is the difference. This distance A1P, this is the extra distance traveled by the wave traveling from the slit A as compared to the wave traveling from the slit B. So there is a path difference between them, right? And how much is that path difference? So A1P, this denotes the path difference. And between the first bright spot, the path difference is considered to be equivalent to the wavelength of the wave, lambda. So as you now see, there are two triangles. First triangle COB, that is this one, starting from C O B. This is a right angle triangle, and the other triangle is A1 A2P. Triangle COB and A1 A2P, they are similar triangles because they both have a right angle at this point. So this is a right angle triangle, this is also a right angle triangle. So their corresponding sides are going to be proportionate. So therefore we would say OB upon OC, that is equal to A1P upon A1 A2. So just comparing the two similar triangles, what are the distances OB and OC? OB is the separation between the two consecutive bright fringes, so that is S. Upon OC is the distance between the slit and the screen, that was capital D. This is equal to A1P, that is the path difference, which is lambda, upon A1 A2, which is the distance between the slits. So therefore, this gives us that the separation between the two slits can be found out as lambda D upon D. So this relationship is very, very important. That is, the separation between two consecutive bright fringes is equal to lambda times the distance between the slit and the screen upon the distance between the slits. So when we know all these three, we can find out the separation between the fringes. And another thing that we need to understand, that when does the constructive interference happens? For constructive interference, your path difference must be n times lambda. So for the first one where n is 0, that is the central brightest spot, the path difference is 0 because n would be 0. For the for the first central maxima, after that you have the first bright fringe, n is going to be equal to 1. So your path difference is equal to lambda. And so on for the for the successive second, third, and fourth bright fringes, your path difference will be 2 lambda, 3 lambda, and so on. And where you're getting the dark fringes, that means for destructive interference, your path difference must be equal to n plus half times lambda. So that has to be an odd integral multiple of the lambda by 2. So when you have integral multiple of lambda, you get constructive interference, and when you have odd integral multiple, this n plus half times lambda means odd integral multiple of lambda by 2. That is when you are going to get the destructive interference or the dark fringes. So for 0, 1, 2, you go on just substituting n is equal to 0, 1, 2, you go on getting the dark fringes. That is the conditions for the destructive interference. So that's all in this video session. In the next video session, you are going to learn about standing waves. Thank you.